Welcome to the group exhibit Hydrogen Fuel Cells and Batteries at the Fraunhofer 2017. We are here at the Technical Forum and my name is Muriel Burkas. Please have a seat, join us, have a drink, have some coffee, it's everything free on the house. I would also like to welcome people watching the live streaming online. Also, if you're interested or if you missed some presentations, all the presentations will be available online afterwards on our website, so you don't have to take too many pictures if you want to watch the presentation later on again. The upcoming presentation will be regarding development of a zero-emission municipal vehicle. Please welcome with me on stage senior scientist from the Fraunhofer Institute for Solar Energy Systems, Stefan Keller.
Yeah, thank you for this nice introduction. Ladies and gentlemen, I would like to welcome you to my talk, and I will introduce you an interesting project we did at the Fraunhofer ISE in Freiburg together with our project partners, where we electrified a small truck. A short introduction about our department. We are part of the Fraunhofer Institute for Solar Energy Systems, as I said, located in Freiburg. Our group, we are specialists in fuel cells and fuel cells technologies for over 20 years now. And our topics are, for example, the characterization of local effects of fuel cells and stack level, the lifetime testing and development of cell stacks and system. We do climate tests, we do investigations on contaminants, and we also do testing of peripherals for fuel cells and fuel cells components, and we also do system development and understanding of system behavior by modulation and simulation, and this is what I'm going to talk about today a little bit with a very nice example, because in this project, it is called Elan in Germany. We have a small municipal vehicle, a small truck, which is shown here. It's called LADOG T1250. LADOG is the manufacturer of the vehicle. And in Germany, LADOG stands for leichte Arbeit durch ordentliches Gerät. So, which is translated in English something like, if you have the right tools, the work is easy to do. So this is what this vehicle stands for. It can be used for different applications, like, for example, making your streets free of snow, or cutting grass, or cleaning streets or pedestrians, for example. Now, basically, the idea in this project is to simply replace the diesel engine and the hydraulic system by an electrical system driven by fuel cell and battery. And therefore, we have an interesting project consortium, and something special about this propulsion system based on fuel cell and battery is that it's not only fitted for this vehicle, but it's a kind of modular approach, so that other applications, like, for example, forklifts or other ground equipment, can also be powered by the power system we developed here. So this is a kind of modular approach regarding the fuel system or the drivetrain system. Now, the project consortium consists of Elring-Klinger, a company which is also here in this hall and provides the battery module and the fuel cells. Heinzmann is a small unit or small company who provides the electric motor. They are specialists in electric motor technologies, also placed here in this hall. Fronius is a partner from Austria. Fronius makes a system integration, putting battery and fuel cell together and assembling all the components around the fuel cell to make a fuel cell system for operating the fuel cell. And LADOG is the supplier of the vehicle, and they integrate all the components finally in the vehicle. What we do in our institute is to assist the system development by modeling and analyzing different load profiles with the models we can operate or we can develop. Now, here's a small approach how the propulsion system looks like. We have a fuel cell system located here. It's composed of two fuel cell stacks, or you can say two separate fuel cell systems, each providing approximately 10 kilowatt of electrical power. And additionally, we have a battery pack which gives the peak power demand, so that the basic energy, the base load is provided by the fuel cell, and the peak power is provided by the battery. And therefore, by using the fuel cell, we can use a hydrogen as an energy carrier, and packaging the hydrogen tanks onto the vehicle allows us to carry on the vehicle a quite large amount of energy. In this case, we have approximately 3.8 kilograms of hydrogen on board, which translates into approximately 60 kilowatt hours electrical energy from the fuel cell system, plus approximately 10 kilowatt hours from the battery system. So this is a hybrid approach consisting of battery power for the high power demand and fuel cell systems for the base load and the energy. Now, the power which comes from this range extending system is fed to the vehicle, and mainly is fed to the electric motor, which is provided by the project partner Heinzmann. The technology here is an 80-volt technology, so a kind of low-voltage technology, and this is with respect to the second application for the forklifts, for example, where this propulsion system can also be used, where an 80-volt technology is a kind of standard, and it also eases things like, for example, maintenance, as you do not have a very high voltage, and therefore the safety level is better or easier to fulfill. What we use from the normal vehicle is the cooling equipment, so that the existing cooling radiators and the piping, which is normally used for the diesel engine, now can be used to cool the fuel cell system and the batteries. And as I said, this modular approach makes it possible to use these or this system not only in this vehicle as demonstrated in this project, but also in other applications, like, for example, a Class 1 forklift, which is if you only use, for example, one fuel cell system and only half of the batteries, you have a propulsion or an energy system which meets the energy requirements of a Class 1 forklift very well. Now, coming to the different components, here I can show you the electric motor. It's due to the fact that we have an 80-volt system and we want to provide 60 kilowatt of power, which is necessary to fulfill the power requirements compared to the diesel engine. So this is what we estimated is a 1-to-1 power demand. And by applying the 80 volts, we have a quite high current we have to supply to the motor. Therefore, the motor consists of 3 motors in one housing, you can say. So we have 3 windings. On each of these 3 windings is a separate motor controller, which enables us to use a normal motor controller off the shelf. And this motor is then connected to a 2-stage gear, which is mounted on the rear axle and provides the power also to the front axle by a normal cardan shaft. So we have a 4-wheel drive, as it is also realized in the standard vehicle. But of course, with an electric motor without any emissions or without noise emissions. Now, coming to the battery, the very base element of the battery pack is the battery cell. Here, the project partner, Elring Klinger, chose a standard case cell. It's a PHEV2 format. This is a kind of standard format which is normally used for plug-in hybrid electric vehicles. That's where this abbreviation comes from. And we arranged 7 of these cells in one module. So one module consists of 7 cells, all connected in series. And in this application, we assembled all in all 12 of these modules in 4 parallel and 3 serial connections, so that we have altogether 21 cells connected in series to fulfill these 80-volt requirements. So this is the approach where from a single cell to a battery module, the battery module is connected, in this case, to meet the requirements by this small truck application. Now, coming to the fuel cell, this is also provided by Elring Klinger. It's an M5 design. In this case, we have 100 cells, all connected in series. The fuel cell stack itself has a dimension of approximately like a normal paper with a height of, let's say 15 centimeters, so it's quite compact. in the end plates, there are also some additional you can say devices installed, which makes the operation more easy, which makes the system design more easy to realize. And around this fuel cell stack, some other components, a few more components are needed. For example, the air supply to make it a complete system, an operating system. And each of these fuel cell systems stack and its balance of plants components is connected via a DC-DC converter to the electric main bus. And with this DC-DC converter, we can, on the one side, adjust the voltage according to the battery voltage and also do an active power management. So with this power electronics, we can separate or actively divide how much power is provided by the fuel cell and how much by the battery. Now the complete arrangement in the vehicle in this case is shown here. So we have the two fuel cell systems on this side here of the vehicle. We have the battery pack in the middle of the vehicle located. And we have the cooling from the normal vehicle on the left side. And the hydrogen tanks are at the rear of the driver's cabin. And as I said before, approximately 4 kilogram and therefore approximately 60 kilowatt hour electrical energy. The motor is located at the rear axle in this area here. And therefore, we can use this system or the setup of the normal vehicle and do not lose a lot of room in this vehicle, but still can provide an electric propelled small truck. Now what we did at the Fraunhofer ISE is the modeling of the complete system. Therefore, we took a simple electric equivalent circuit model for the battery, shown above. And for the fuel cell, we took a physical model. And the aim of this modeling is to give some information about the behavior or about the dependency of, for example, temperature or voltage of the different elements when you apply different load scenarios, so that you do not have to test the real equipment when you, for example, want to investigate different operating strategies, but simply can do it with the models here. And that these models work and that we did our work correct, you can say, is shown here. So we validated the models with existing data. So you see here the black spots are real measurement data provided by the manufacturer of the fuel cell. And the red one is what the simulation would give you. The same here, displayed for time curves of different data. Again, we have the measurement data here in black and the simulation in red quite close to each other. The same is true for the temperatures. So therefore, we can say the model are quite confident, and we can use them to investigate different operating strategies. And one of these examples is shown here. So what we can do here is apply a certain load profile, for example, and see how the state of charge, for example, of the battery depends on this load profile, and how the C rate for the battery will be. And this, in this case, is done for a constant power from the fuel cell system. But of course, so this is the base where we now can investigate different operating strategies and also optimize the different configurations and the different strategies how the fuel cell and the battery can work together for a certain load profile. Yeah, and with this, I'm quite at the end of my presentation. I want to thank our funders. So on the German side, the project was funded by the Ministry of Economics and Energy, and on the Austrian side, it was funded by the FFG. So thank you for your interest, and you're warmly welcome to visit us at our booth. It's at C62, just this direction. And I can recommend, we have a very good coffee there, a special Schwarzwald coffee, and also some sweet things to eat. So please be welcome at our booth. Thank you.
Thank you very much, Stefan Keller. Are there any questions from the audience right now? If not, I would like to know, it's a great example for the municipal vehicles. Are you planning on bringing this, leveraging this solution for other vehicles? Could you install this also for bigger vehicles, or do you have anything in mind?
Yeah. Yes. Now, one example was the forklift. So this is something where also the project partner Fronius is quite interested in, as they already have similar applications, but not in this power class, you can say. So these 10 kilowatts base or average power, peak power is more. This is interesting to have half of this propulsion system in a forklift application, for example. So this is one thing. And the different components, the battery modules, they of course can also be arranged in different scenarios to, for example, also power an electric vehicle. And the same is true for the fuel cell stack and also for the fuel cell system there. It can be scaled to supply also applications with a higher load demand. In this case, which is a little bit special, is this 80 volt approach. This mainly comes from the requirement of let's say not so high power demand, up to 60K, but quite high safety level to not to go too high with the voltage, therefore.
Great. Thank you very much. Please have a visit at their booth C62 later on. Warm applause for you.
Thank you.
We will continue with our next presentation in a few minutes regarding customized test rigs and system components for fuel cells and electrolyzer by EBZ Entwicklungs- und Vertriebsgesellschaft Brennstoffzelle GmbH. Please stay with us, have a coffee, have some drinks, and see you in a few minutes. Thank you very much.